welcome back. In this video we're going to talk about a new property which is called density. Now this video will concentrate more on the concepts related to density. Okay, we will see some examples of how to work out problems in another video. Before we actually see what density is, let me ask you a simple question. Which is heavier, wood or iron? What do you think? Well, most of us would immediately say iron, of course. Iron is heavier than wood, isn't it? But wait. Are you telling me that a small iron nail is actually heavier than a big tree? I don't think so, but isn't that what you are saying? I mean, the nail is made out of iron, and the tree is made of wood. Aren't they? Well, of course, the comparison here that I just made isn't really fair. But why isn't it fair? It isn't fair because the two objects we compared were not of the same size. If, on the other hand, we compare nails of exactly the same size and shape between wood and iron, in that case, yes, the iron nails will be heavier. So a certain volume of iron is heavier than the same volume of wood. And in physics, a special term is used to carry out these comparisons. This is what is called density. And density gives us a relationship between the mass, how heavy that is, and the volume, cioè the size of an object. And density is defined as the mass per unit volume. This is the official definition that you need to learn for your exams. So if you are asked to define density, you need to state specifically that density is defined as the mass per unit volume. As a formula, density is given by the following that you can see in front of you. Now remember that in physics or in science or in maths and so on, pair means division. So when we say mass per unit volume, it means mass divided by volume. So density is equal to mass all over volume. So, the symbol for density. Now here we're going to meet another Greek letter. We've already seen the Greek letter mu, which represented micro. We knew about pi. So now we have another letter, another Greek letter, which is the letter rho. And that is that sort of funny P or strange P that you're seeing written over there. Okay? This is the symbol that you should use as much as possible for density. Okay, avoid using the small letter d to represent density. To a certain point, even in the exams, it's better that if it's either you use the symbol rho or else write the word density in full as a whole word. So when we look at the formula in terms of symbols, okay, so remember the formula was density equals mass all over volume. So the formula comes rho equals m all over v. M represents mass, small letter m, capital letter V represents volume, and rho represents density. What about the units for density? Well, let's reason those out from the formula. We said that density is equal to mass all over volume. Now the SI unit for mass is kilograms, and the SI unit for volume is meters cubed, and hence the SI unit for density is kilograms per meter cubed. Sometimes we shall also use grams per centimeter cubed in our problems, which is okay if the question permits it. But remember that the SI unit of density is kilograms per meter cubed. So if in the exam you are asked to quote the SI unit, it is kilograms per meter cubed. If you get mixed up remembering this, just reason out from the formula, like we just did. You will get used to the formula and the units with some practice. But for now, let's concentrate more on understanding the property of density. Density depends on the material and will always be fixed for a certain material irrespective of its shape and its size. For instance, in the case of iron, whether we have iron keys, whether we have screws or nails which are made of iron, whether we've got tools, weapons, or even Iron Man himself, the value of density of iron is always going to be the same. And likewise, anything made from steel will have the same density, anything made from the same type of wood will have the same density, etc. So look at this table now. In the first column we've got the materials, and then in the second and third column we've got different values of density. The second column is the value of density in grams per centimeter cubed, while the third column is the value of density in kilograms per meter cubed. Alright, so these are typical examples of approximate values of densities for certain materials. We've got air, water, aluminium, iron and gold. Air being a gas, also it is something which is very light, okay, and so its value is actually very small, as you can see over there. We're talking about air at normal conditions, normal pressure, okay, standard atmospheric pressure. If we look at water, which is fresh water, it is next in line, and it has a value of around 1 gram per centimeter cubed and 1000 kilograms per meter cubed. Slowly, when we're considering the same volume, you note that the value of the density is increasing. So water is heavier than air for the same volume. Aluminium, 2.7, is heavier than water and heavier than air for the same volume. Iron is even more heavy than air, water and aluminium. As you can see, the density is 7.8. And finally we've got gold in our table over here. Gold is heavier than the four others. It stands at 19.3 density. Okay, so you can see that for the same volume, gold is much heavier than even iron. Look at the difference. Right? If we compare gold with water, gold is a little bit more than 19 times heavier than water, because water has a density of 1, gold has a density of 19.3, so considering the same volume. And this is how you need to learn to interpret the values. Another point that you should realize by looking at the table is the conversions from grams per centimeter cube to kilograms per meter cube. Can you note the pattern from the two columns? In fact, all you have to do is multiply by 1000 to convert from grams per centimeter cube to kilograms per meter cubed, and to convert the other way you just divide by 1000. The easiest to keep in mind is the one of water. Look at the one of water. 1 gram per centimeter cubed, 1000 kilograms per meter cubed. Alright? You don't really need to learn these values. Values of densities are usually either given or we will be asked to work them out in the exams. There is, however, one exception, which is that of water. Okay, the value of water, which is 1 gram per centimeter cubed or 1000 kilograms per meter cubed, is a value that you are expected to know for your exams. Okay, but at least it's not something difficult, and it will also help you to keep in mind the conversions. Alright, so remember the two values for water in grams per centimeter cubed and in kilograms per meter cubed, because it will also help you with your conversions. Now have a look at this. Have you ever tried to mix different liquids in the same container? What happens? For example, here you're seeing a small glass which is filled with some water and some cooking oil. And sometimes when we mix liquids together we see a nice separation, even a rainbow effect if you've got liquids of different color. But why does this happen? Well, it has all to do with density. Density of water is 1 gram per centimeter cubed, while that of cooking oil is about 0.9 grams per centimeter cubed. But what does this mean? This means that for the same volume of material, water is heavier than oil. And because it is heavier, it will move to the bottom, while the oil will end up on top of the water. And it doesn't matter in which order you place these liquids in the cup, eventually the same result will be observed. And this brings us to another very important point with respect to density, that of objects which float and sink. Objects floating and objects sinking. Density is not the only property which determines whether an object floats or not, but it is a very important one nonetheless. Consider a piece of wood floating in a lake, like you see over there. The density of water is 1 gram per centimeter cubed, while that of the wood, for instance, is 0.7 grams per centimeter cubed. So what does this mean again? This means that for the same volume, wood is lighter than water. And this is the effect that we see. Because wood is lighter than water, it floats. So water is heavier and it will move to the bottom. Wood is lighter and it goes to the top. And this is how you have to reason these things out and reason out what density means. Here we have an example which is looking at the other end. If we have a piece of iron, right, for instance, and we throw it in water, like here you've got an old anchor which is being thrown in water, what happens? The piece of iron will sink, obviously, that's what we will say. But why does it sink? Well, iron has a density of 7.8 grams per centimeter cubed, compared to that of water, which is of 1 grams per centimeter cubed. So iron is more dense, it is denser. And because it is denser, it will sink to the bottom. Okay? Whereas the water, which is lighter, which is less dense, will be on top, will float. So remember that if the density of the object is less than that of the fluid it is in, the object will float. If it is greater, it will sink. And if it is the same, we didn't really mention that, but what will happen is, in fact, it will remain in the same level. If an object has the same density as the fluid, it will not sink and neither will it float, it will just remain where it is. Note that I said fluid, not liquid. Now remember, a fluid is a liquid or a gas. And in fact, these principles of density apply to both liquids and gases, and that is why we tend to use the word fluid. The examples we've seen so far were liquids. Just to mention an example with a gas this time, we can consider a hot air balloon, for instance. And how does this work? Hot air balloons have burners at the bottom, and the job of these burners is to heat up the air found inside the balloon itself. As the air inside becomes heated, the air particles expand, and on expanding, the air inside the balloon becomes less dense. Since the warm air is less dense than the colder air found outside, it will float, and this moves the balloon up. Hot air balloons have a valve system to allow warm air to escape, and this introduces colder air back inside. As the air inside the balloon becomes cooler, it becomes more dense and so slowly starts to sink. That is, it starts to move back down. And this process is repeated by the pilot of the balloon to move it up and down. And in fact, this concept leads us to a very, very important observation in physics, something which we'll meet quite a number of times throughout our studies. Hot air rises and cold air sinks. Okay? Hot air rises because it is lighter, because it is less dense, so it rises. Colder air is heavier, it is more dense. And the same applies really for any fluid, any liquid or any gas. As a final note, we mentioned something about experiments. Experiments where we need to find the density of an object. First of all, just remember that density is the mass per unit volume. Okay, mass division by volume. So this means that to find the density of an object, we need to know two things, primarily the mass and the volume of that object. Remember also what we mentioned on volumes of regular and irregular objects, which we had discussed in an earlier video. Okay, because everything now will start coming together. Suppose we need to find the density of a box, a regular box. First, we find the mass of the box, and to do this, we can use an electronic balance. We can use other pieces of equipment, but an electronic balance will be the easiest way of doing it, probably. And next, we need to find volume. Being a regular object, being a cuboid, okay, we just use volume equals length times breadth times height. So we measure the length, the breadth, the height of the box, multiply them with each other and find the volume. Once we know these two quantities, we know the mass and we know the volume of the box, and then we just use our formula. Density equals mass over volume. We divide the two values and find the density. Okay, remember, rho equals m over v. Density equals mass over volume. Now suppose we need to find the density of an irregular object, like a stone. Last time we mentioned stones, so let's find the density of a stone. First, again, we can find the mass of the stone just by using the electronic balance. Okay, make sure the balance is 0. Before you start, place the stone gently and record the value. Then we need to find the volume of the stone, and we find the volume using the measuring cylinder as we had explained in the previous video. Alright, it is important to find the mass first, in this case, as the stone will still be dry. If you find the mass of the stone after it is placed in the water, it will be wet. Being wet means that it has some water molecules, water particles with it, which means that our results will be slightly inaccurate. Okay, so keep in mind that first we take the mass of the object and then we place it in the water. And once again, once we know these two quantities, we know our mass, we know our volume, we simply need to use the formula. We use the formula, okay, to obtain the value of the density of the stone. So as you can see, the procedure is very similar. We find the mass, we find the volume, and then we work out the density using our formula. What if we are asked to find the density of a soft drink, for example? It can be a soft drink or it can be any other liquid, because we talked about a solid, right, previously. Sometimes you need to think a little bit outside the normal context, but it always helps to keep an eye out on your actual formula. And this applies to anything we do in physics. Remember that to find density we need two quantities, mass and volume. So that is what we have to figure out. But hold on a sec, we cannot just pour our liquid on our electronic balance to find the mass. That will make a big mess. We don't really have obtained anything, would we? So think, how can I find the volume and the mass of a liquid? Well, we can find the mass of an empty beaker or measuring cylinder first. Pour an known amount of the liquid which I need to find inside it. For example, I pour 100 centimeters cubed, so I know the volume because I know how much I am pouring. And then I find the mass again of the beaker and the liquid together. Once I have these two values of the mass, I simply subtract. So we subtract the two values of the mass. One mass was the beaker on its own, the other was the beaker and the liquid. If I subtract them, I get the mass of the liquid. Once we know these two quantities, once again we just use the formula to find our density. Okay, and this will apply to any situation we are given. So don't be afraid if you are given a situation which is slightly different. Always keep in mind these two things, that we need to find our mass and our volume to find the density. And once again, follow your formulas. The formulas help us and guide us a lot. Okay, and don't be afraid to think outside the box. Well, that's it for this lesson. In this video we talked about density, we saw what it is, the definition, the formula, the units. We also discussed the important property of floating and sinking, and also looked at some procedures when it comes to finding the density experimentally. So I hope that you liked this video, and thank you for watching.